Picking up almost where we left off here, I'm showing you a couple of the aging options here with static, time, and type. And we're going to go back to the board for a quick explanation of all four of these options. But I wanted to show you those aging options. Of the four that you see there, aging, MAC address, maximum, and violation, you're going to use those last three often in the real world and probably your exam prep as well. Aging, I'm going to show you the options, but you could go a long time without ever changing the default aging for secure MAC addresses. And I'll tell you why. It's because it's 0. Because, again, by default, dynamically learned secure MAC addresses don't age out, and the static ones certainly don't age out by default. If you need to change this for some reason, you can use those aging options. Now, the option to age out static addresses is rarely used, but it is there with choosing that static option. But if you want to change the time and type that we're working with as far as port security age outs, you can use time to set the number of minutes an address should remain secure. Now, note the range here is 1 through 1,440. You can't set this to 0 because by default it's already set to 0 and the addresses are not going to age out. So you could change it there. It is the aging time in minutes. And as for those timer types, you can run one of two types, absolute or inactivity. And the absolute timer is like just a countdown clock. You set it to 10 minutes and it's going to start and it goes down to 0 and then that address is no longer considered secure. The inactivity timer, though, is going to refresh when the source MAC address is heard from. If you use the absolute timer, switch doesn't care. You can hear from that particular source MAC address over and over again in the time period you set, and when that timer hits 0, it hits 0. Again, the inactivity timer is going to refresh every time the source MAC address is heard from. Now, again, the aging options, not going to use those very often, but this one you'll be using quite often, the maximum option, because it allows us to change the number of secure MAC addresses the port can learn. The default is 1, and that's going to fit a lot of situations, but not every single one. Now, the maximum number really depends on your switching model. The lowest I've ever seen is 132. So you're going to have plenty of working room one way or the other. In the switch that we're on right now, you can see I could set 6,144 secure MAC addresses on that single port. I would suggest you not set 6,144 secure MAC addresses on a single port unless you have a darn good reason for doing so. Someone must have a reason or they wouldn't have set the range that high. Now with the MAC address, this option allows us to define two kinds of MAC addresses. The first being static secure MAC addresses. That is just the ones that we configure ourselves. We'll do that shortly. And something called a sticky secure MAC address. That sounds pretty disgusting, doesn't it? But it's actually helpful, and we will do a separate lab on sticky secure MAC addresses so you know exactly what's going on there. I just want to introduce you to the command for right now. The violation option, we got to be all over this one, because this defines the action taken by the port when a non-secure source MAC address is detected. Now, the three modes take, for the most part, different actions or different levels of action, but all three modes will drop the offending frame, which certainly makes sense. The three modes are protect, restrict, shutdown. And shutdown is the default. Now, we saw that under security action in the previous video under show port security. And remember I was telling you, don't confuse that with an action that's already been taken. But shutdown is our default mode, and this is the strongest security level of the three. Because when a non-secure source MAC comes in, this mode puts the port into what we call error disabled state, or often called just error disabled state. Just drop the OR there. And manual intervention is needed to reopen the port. You and I, the network admin, we got to connect to that switch, we got to shut the port down and then reopen it. We have to reset it. And a simple network management protocol SNMP message is also generated. Now, restrict mode is going to generate both an SNMP message and a syslog message. The port is going to remain open. And protect mode, besides dropping the frame, protect mode doesn't give us anything else. So be very clear on the differences there. They all sound good, protect and restrict and shutdown. They all sound great, but obviously some very important differences there. Now we're going to start seeing port security in action, and we're going to start with the fundamentals. We're going to move on from there. And the switch ports leading to the host have been configured as access ports. I've already taken care of that. Host 1 can ping host 2 with no problem. I'm going to use Cisco routers as our hosts, which is why the pings look like they do. But this is what we're working with. And you can see the MAC addresses assigned to each host. You can see the IP addresses assigned to each host. We may use all this information. We may not, because, of course, on Cisco exams, job interviews, etc., you can be given information that you're not necessarily going to use. But I want you to know these MAC addresses. And when we pick up at the beginning of the next video, this is a long lab we're starting with, so I want to make sure we get it all in one vid. We'll pick up right here and we'll dive into our first port security lab.